Okay, everyone. Now we do again continue with this type of hydrogen atom, series of hydrogen spectrum. Sorry. Okay. Now in the last YouTube video, we did up to the two series, Lyman series and Balmer series. Okay. Now we'll be doing with the third series of hydrogen spectrum, which was observed by Paschen itself, and the name of the series is called Paschen series. Okay. Now this is the third series of hydrogen spectrum. Now in this series, if you see, the hydrogen spectrum, the emission of radiation from hydrogen atom takes place when electron jump from what? When electron jump from the higher orbits, and these higher orbits are nothing but 4, okay, 5, 6, dot like that. That means the higher orbit is n2, which can be written as n, and this will be 4, 5, 6, dot. It can go up to infinite series. Because when electron jump from 4 orbit to the lower orbit, now in this case the lower orbit will be, the lower orbit in this series is n1, and this series lower orbit is how much? 3. Means when electron jump from 4 to 3, we get Paschen series. 5 to 3, Paschen series. 6 to 3, Paschen series. Infinite to 3 also Paschen series. So in Paschen series, children, remember this, the electron has to jump from higher orbit like 4, 5, 6, 7, it can go up to infinite series, to the lower orbit, that must be 3. Okay, so with this we can write the relation that measure the wavelength of emitted radiation under Paschen series, and this is given by 1 by lambda equals to r bracket 1 by, now n1 is 3 square, minus 1 by n2. Now n2 may I write on n with whole square, where n starting from 4, 5, 6 like that. It will go on and on. So look at the relation that measures the wavelength of emitted radiation in Paschen series. This is the relation. 1 by lambda equals to r bracket 1 by 3 square minus 1 by n square. When n starting from 4, 5, 6, it will go on and on up to infinite series. Now, while measuring the wavelength emitted under this series, okay, Paschen found that the wavelength which was calculated under this series was obtained in one of the radiation or one of the spectrum of light, and that is called infrared region. That means Paschen series lies in what? It lies in infrared region. The infrared region is one of the spectrum, electromagnetic spectrum, okay, one of the electromagnetic spectrum, okay, which is produced by the light, by the what radiation? Light radiation. So Paschen series also falls under infrared region. Okay, so remember this point, children. This will be asked in the examination. In which electromagnetic spectrum the Paschen series lies? Infrared region or infrared spectrum. So this is the observation which was made by Paschen under the hydrogen spectrum. Now we have another spectrum that is called Brackett spectrum. Brackett series, sorry, another series called Brackett series. This is Brackett. Okay, let me write the spelling. B-R-A-C, okay, K-E-T-T, Brackett series. This is called Brackett series. Now Brackett series is one of the type of hydrogen spectrum, okay, which was observed by the Brackett itself. This is the name of the scientist, and this series was obtained when electron, basically this series will obtain when electron jump from what? Jump from higher orbits, and the higher orbit which is marked by n2, and this n2 can be written n, and the higher orbit must be 5, 6, 7, dot up to infinite. That means when electron jump from higher orbit like 5 to the lower orbit, and in this case the lower orbit must be, and I don't know, the lower orbit which is marked by letter n1 must be how much? 4. So in Brackett series, the electron has to jump from 5 to 4, 6 to 4, 7 to 4, or infinite to 4. So when electron jump from this higher orbit to the lower orbit, say 4, we obtain the series of hydrogen spectrum, okay, and this series of spectrum is usually called as, this series is basically called as Brackett series. So Brackett series is one of the type of a series of hydrogen spectrum. obtained under these orbits. Okay, so this series can also be written. This series can measure the wavelength also of emitted radiation, and this wavelength of emitted radiation can also be measured by the formula 1 by lambda equals to R bracket 1 by now n1 square. Actually the general formula is n1 square, but n1 is what? 4, I write on 4 square, minus 1 by n2 square. Now n2 means n only, I write on n2, because your n2 starting from 5, 6, 7 dot dot dot, it will go on and on. So you can see the relation, children, which measure the wavelength of emitted radiation on the Brackett series. 1 by lambda equals to R bracket 1 by 4 square minus 1 by n square, where n starting from 5, 6, 7 dot 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 up to infinite series. Okay. Now, as per the observation which was made by Brackett, this series of spectrum was also obtained in one of the region called infrared region. So remember this series was also observed in what? This series was also observed in which region? Infrared region, one of the type of electromagnetic spectrum. Okay. Now, because infrared radiation region has a longest wavelength, which has a maximum more wavelength. That's why Brackett series also falls under infrared region. Okay. Now we have a last series of hydrogen spectrum, and this is number 5. And this series is called Pfund series. Pfund series. So this is the last series of hydrogen spectrum observed by Pfund only. Okay. Now this series was obtained, okay, when electron jump from the higher orbit. So in this series, let me just write down. This series obtained when electron, okay, jump from what? Electron jump from higher orbits. Electron jump from higher orbits, and that higher orbit is marked by letter n2 equals to n, and the higher orbit must be what? 6, 7, 8 dot dot dot. It can go up to infinite series, infinite orbit, to the lower orbit. And the lower orbit is n1, and this must be 5. So what is the lower orbit in Pfund series? 5. And what are the higher orbits? 6, 7, 8, 9, and like that. Which means when electron jump from orbit 6 to orbit 5, we get Pfund series. Sorry. When electron jump from 7 to 5, Pfund series. When electron jump from 8 to 5, Pfund series. It will go. We get Pfund series when the electron jump from this higher orbit to the lower orbit, that is 5. Okay. So under this series also we can measure the wavelength emitted by the hydrogen spectrum, under hydrogen spectrum. Okay, and this wavelength can also be measured by the formula, that is 1 by lambda equals to R bracket 1 by n1 square, it is 5 square, minus 1 by n2. Now n2 means n square. So the formula is 1 by lambda equals to R bracket 1 by 5 square minus 1 by n square. So this is the relation that measures the wavelength of emitted radiation under Pfund series. And as I said, n must be starting from 6, 7, 8 dot 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 up to infinite series. Now this series was also obtained and observed in which region? Infrared region. So this is also observed in what? It is also observed. It's also observed in which region? Infrared region. Infrared region. So look at the region where this Pfund series, Brackett series, and Paschen series obtained. All in what? Infrared region. Whereas Balmer series we saw obtained in what? Visible spectrum, visible region, and Lyman series is the only series which obtained in what? Ultraviolet what? Region. So these are the series of hydrogen spectrum which was observed by different scientists. Okay. Now this series of spectrum can be expressed even with the help of a diagram called energy level diagram for the emission of hydrogen spectrum. And this energy level diagram for the emission of hydrogen spectrum followed by the absorption transition of hydrogen spectrum, that you will be learning in the next class. So we will continue with the same chapter in the next class. Thank you so much.